This video is a little bit of an overview of what we're going to be doing in our ASO neutralization testing lab this week. And I kind of want to go through it because there's a lot of tubes, there's a lot of moving parts, there's a lot of steps, and so it's pretty convenient to sort of think about it early rather than right when we get into the lab. Otherwise, it's more confusing than it needs to be. When we talk about this test, what we are checking for in this specific test, but it could be expanded to other types of things, but we are looking to see, has this person, this patient with whom we've drawn a blood sample and collected their serum, have they had a strep infection before? And the way we're going to know if that has happened or if it's currently happening is based on the presence of ASO antibodies in their serum. And ASO stands for anti-streptolysin O. When you get strep, it can be strep throat, and if it's worse, it can actually get to other parts of the body. But either way, if you have exposure to strep, you make an antibody to it. And what it is you're actually making an antibody to is a toxin called streptolysin O that is produced by the strep bacterium. And when you have that exposure and you generate those antibodies, of course, we have memory cells that are going to persist, and they are going to continue to produce those antibodies even after you have cleared the infection. So you always kind of have a low-lying titer of antibodies in your system if you've had exposure. This applies to any sort of foreign pathogen antigen that comes into our system. So in this situation, we are asking ourselves, does this patient, have they ever been exposed? Number one. Are they currently exposed? Do they have a really high titer? Or have they been exposed recently and they're kind of coming down? So that's what we're setting the stage as. So in this tube right here, what I want you to think about is, let's consider a patient who has the anti-streptolysin O antibodies. So they have been exposed at some point and they have generated the antibodies. We don't know if it's a current infection or not, but either way, we know that they've got them. And as you'll see when you read through the lab directions, we're going to be adding their serum. We're going to dilute it and we're going to add it to a bunch of different values of buffer and kind of make a series of dilutions, that serial dilution thing we talked about before. But we're going to keep it simple in this video just so we understand sort of the theory behind what we're doing. So in this case, we have a patient serum, and that patient serum has those ASO antibodies in it. And we have mixed it with some buffer, which is one of the reagents we use in this test. The next thing we're going to do is actually add a commercially prepared reagent of streptolysin O. So this is the same toxin that the pathogen would make, the strep would make, and it is purchased from a company, and we add it to this patient's serum. Now, if the patient's serum has anti-streptolysin O antibodies in it, those antibodies will bind and neutralize the streptolysin O. If it didn't have anti-streptolysin O antibodies, ASO antibodies, then the streptolysin O would be added to the tube and there would be no neutralization. When I say neutralization, what I mean is it basically inactivates the streptolysin O. Streptolysin O is capable of destroying cells. It's a lytic sort of toxin. That's what the lysin part is. So if it were to be not neutralized and mixed with red cells, it would lyse the red cells. However, if we neutralize the toxin with antibodies from a patient's specimen, then that streptolysin O becomes inactive. So how do we know if there has been binding of antibodies to SLO? We have to add some sort of visual step to this because we can't see this happening, right? These are all very soluble small molecules. So the next step in general here is to add red blood cells to this mixture. If the patient has anti-streptolysin O antibodies, they will have bound to the streptolysin O that was added to the tube. If they bind it, they neutralize it. If I add red blood cells to this tube, that means the SLO has been neutralized. There is none that is free to lyse the red cells, and the red cells will stay whole. There should be no hemolysis. So that would be an indicator that my patient has had exposure to strep and they have made anti-streptolysin O antibodies. And this is good. This is qualitative. But what if we want to get a little more quantitative. How much do they have? What is their actual concentration of antibodies? Is there a point where I add SLO and I don't have enough antibodies to neutralize it? Those are kinds of the things we're going to take a little further in this lab. If we look at the flip situation, you have a patient who has never been exposed to strep before, so their serum does not have anti-streptolysin O antibodies. If I add the commercial streptolysin O, there are no antibodies to neutralize it. So that stuff just floats around in our little buffer serum dilution, and it has not been neutralized, so it still is fully functional and capable of destroying cells. So when I add red blood cells to it, what happens is the red cells will be hemolyzed by the free streptolysin O. And in this case, that's an indication of one or two things. Either this patient has never had streptolysin O in their system, so they've never made antibodies, or perhaps we've gotten to a point where we've diluted the patient specimen out so much that there's not a lot of antibodies left to neutralize the strep. So that's going to be what we'll look at on the next slide. Either way, when there is hemolysis in a tube, that indicates that our streptolysin O was not neutralized and that it was free to bind and destroy the red cells. If we want to actually get a titer, so how concentrated with anti-streptolysin O antibodies is my patient specimen, we have to set up this big old series of tubes 1 through 14, basically. And what you're doing in each of those tubes, 1 through 12 anyway, is we are going to be diluting out the patient specimen. So as the tubes are kind of going from low to high number, there's going to be a dilution of the antibodies in the tubes. Eventually, we are going to dilute out the antibodies so much that there's not enough to neutralize the SLO toxin that is present in the reagent. At some point, you should then see some hemolysis due to that excess SLO toxin because we cannot neutralize it. So if you look at our tubes here, you can see obviously in the low tube, the early tube, there's more than enough antibody to neutralize the toxin. The next tube, it looks like we have enough antibody to neutralize the toxin. Getting a little bit different here at tube 100, but still enough. Okay, now we're starting to see some free SLO in tube 125. There's more free SLO in tube 166, and there's completely free SLO in tube 200. So basically we have diluted our specimen out, and when you look at the instructions, you'll sort of see how we prepare these dilutions. But we've diluted our patient sample out to the point where there's not enough antibody present to bind to the SLO that we add. So if you had to predict which of these tubes would show hemolysis, maybe think about before I give you the answer, which one would show hemolysis? Where do we see that free SLO capable of destroying red cells? If you add your red cells to all of these tubes, you would expect to see hemolysis in tube 125, and that's because that is the first tube that has free SLO in it because the antibodies have been diluted out enough to not have enough to neutralize the SLO. You would also expect to see hemolysis in pretty much all the tubes following that 125 because all of them have free SLO that has not been neutralized by antibodies. Basically means that the SLO is going to destroy the red blood cells and you should see hemolysis. So you can kind of get a feel for, how concentrated is this patient's serum. Obviously, if these tubes did not hemolyze all the way up to the 200 tube, that would mean, wow, we really started with some very concentrated patient serum because even when I diluted it out 1/200th, it was still capable of neutralizing the SLO that was present. And that would indicate to me that there's probably a very current or recent infection. So the longer it takes basically for the tubes to hemolyze, the more concentrated the patient's antibodies are in their serum sample because we're really diluting it out. And even diluting it doesn't dilute it enough to, make it weaker. This tube, the 100 tube, is the last tube showing no hemolysis. And this is the tube that you use to calculate titer. So when you're asking, like, what is the titer of this patient's ASO antibody, you would go to the last tube showing no hemolysis and then take the reciprocal. So the 1/100th tube is the last tube showing no hemolysis. You take the reciprocal of that, and that's where the 100 comes from. So we would report this patient's titer out as 100. This chart basically is a chart that shows you how much of each of these different solutions you put into each tube. So you can see that there's a lot of numbers, there's a lot of moving parts, and there's a lot of potential for error, right? So what you need to do is we need to make sure that we're not screwing up. We always have to have controls, right? We've talked about this control thing, and it still applies, especially in something that's so driven by manual action, right? Tubes 13 and 14 are what we call our control tubes. So 13 and 14, if you look at what's in them, the first tube, tube 13, just has buffer and red cells, whereas tube 14 just has buffer and SLO and red cells. And each of those is testing the reagents. Tubes 13 and 14 are kind of reagent controls. In tube 13, with just buffer and red cells, when you add the red cells to the buffer, there should be no hemolysis, right? It's just red cells floating around in saline. If the red cells are healthy, then nothing should happen. If you make this tube and you incubate it and your red cells hemolyze, that is a sign that our red cells were not good. They're probably old or something was wrong with them. Maybe they were fragile, but it indicates to us that one of our reagents wasn't good and that we cannot trust the answers that we're getting on our titration, because maybe those cells hemolyzed just because the cells were bad, not because of the ASO concentration. Tube 14 is the SLO control buffer. The SLO is the streptolysin O. Remember, that's a reagent that we add. And we want to make sure it works, right? Like, what if the SLO was outdated and it wasn't able to hemolyze red cells anymore because it's too old or it's sat out or who knows what? So you set up tube 14 in order to make sure that your SLO is still functioning. So you have buffer, you have red cells, and SLO. If there's nothing else in there, nothing to neutralize the SLO, you should see hemolysis. If you do not see hemolysis, that indicates that you basically have an issue with your SLO. So again, you can't trust your results because maybe there's no hemolysis in them because your SLO was bad, not because of, patient antibodies or lack of antibodies. So keep in mind that 13 and 14 are SLO and RBC controls. They are making sure our reagents are working correctly. The one thing they're still not checking is, did you do it right? Okay, so you can have all the reagents working perfectly, but if you screwed up your tubes, then we're going to have some trouble. So you're going to set up what's called a standard control. And this is a procedural control. This is going to be something that you use to make sure you did it right. Like, you actually put the right amounts of the right things in the right places. So you're going to set up, in addition to tubes 1 through 14 for your patient, you're actually going to set up a little subset of those tubes, so a separate set of tubes 3 through 7 and 13 and 14 using a known standard. So rather than using patient serum, you're actually going to use a standard, which is something that you purchase from a company. And with that standard, you are going to follow the directions as though it was serum for tubes 3 through 7. And then in the end, if you did everything right, your standard tubes should read 166. If you do this all and you set up your standard tubes and your standard tube titer does not read 166, then that means you did something wrong. There was something wrong with the procedure and it needs to be redone. So you have kind of 3 levels of control. We're checking for the red cell functioning, we're checking for the SLO functioning, we're checking for you. Are you doing your pipetting right? Are your volumes correct? All of that stuff. So that's what those second set of tubes is for. And I'll go into this a little bit more when we go into class. And you'll see here again, you're just going to be setting up 3 through 7, and there's actually going to be a separate tube that is SLO, or not SLO, excuse me, it'll be labeled standard control or SC, and that's what you're going to use instead of patient serum. when you set them up. That's the summary of the ASO neutralization testing. I know it's a lot. There's a lot of things to think about and a lot of things that sound similar, and it's hard to kind of keep everything straight. We will go over this again just briefly before you actually get to lab. As you can imagine, this can take some time, right? There's a lot of pipetting, there's a lot of, which tube is which kind of situation. So do your best here, and come to lab with questions. It would be really helpful if I know where you're stuck so that we can move forward faster. If you have questions ahead of time, feel free to reach out to me, email, whatever it is that works best for you.